So if you've been paying any attention to the world of AI, you've definitely seen these giant, almost kind of crazy numbers being thrown around. Every single time a new model gets announced, the headlines are all screaming about one thing: parameters. We're talking billions, sometimes even trillions of them.
You see a headline just like this, right? And it sounds incredibly impressive. A trillion of something. It's totally become the main number everyone uses to measure how powerful an AI is supposed to be.
So what is a parameter, really? And how does having a trillion of them all of a sudden make a machine smart? Well, that's the big mystery we're going to solve today. And I promise you, by the end of this, it's all going to make perfect sense.
Okay, let's do it. Let's pull back the curtain on this whole billion parameter or, trillion parameter mystery. It's actually a lot more straightforward than it sounds.
At its absolute most basic level, a parameter is just a number. Seriously, think of it like a single tiny knob or a dial inside the AI's brain. The model is just packed with billions of these little knobs, and all together, they hold all the knowledge that it's learned.
Now, to really make this concept click, let's forget about all the code in the computers for a second. I think the absolute best way to get this is with a pretty simple analogy.
I want you to picture a gigantic audio mixing board. You know, the kind you'd see in a fancy recording studio. But this one, it doesn't have just a few dozen sliders. It has billions, maybe even a trillion. It's this unbelievably complex control panel. So here's how it all connects. Each one of those parameters in an AI, that's one of those tiny little sliders. The whole training process you hear about is really just the process of adjusting every single one of those sliders again and again and again until it finds the absolute perfect combination. That final setting, the exact position of a billion different sliders, is what creates the AI's unique sound. You know, whether that's writing an email for you, generating a picture, or answering your questions.
And this, right here, this explains what is literally happening when you download an AI model. That file, which can be huge, gigabytes in size, is basically just a massive, massive list of numbers. You are downloading the final, perfectly tuned positions for every single one of those billions of sliders.
So let's see what this looks like out in the real world with some models you've definitely heard of. The sheer scale of these digital mixing boards has just absolutely exploded over the last few years.
You know, the early models, they were working with millions of parameters. Then bam, GPT-3 came along with 175 billion, which was just this monumental leap that changed everything. But what's really cool about this slide is that the newer models, like Llama 3, show that you don't always have to get bigger. With only 8 billion parameters, it's actually incredibly efficient.
Yeah, it was that massive parameter count in GPT-3 that let it do really complex things like writing whole essays. And for image models like Stable Diffusion, their billions of sliders are all tuned to connect words with pixels. And then you've got these super efficient models like Llama 3, where 8 billion well-tuned parameters are powerful enough to run right there on your laptop. So this brings us to a really, really important question. If more parameters mean more capacity to learn, does that just mean the biggest model is always the best one? Well, not exactly. Think about it like this. A smaller 8 billion parameter model, if it's trained on really, really high-quality data, can easily outperform a massive 70 billion model that was trained on messy, low-quality junk. So the smaller model isn't just better, it's also way cheaper and faster to run. It's all about the quality, not just the quantity.
So while the parameter count is a useful, quick way to guess the model's potential power, it's really just one piece of the puzzle. The quality of the training data and how the model is built are just as important, if not even more so.
Okay, so you get it now. You know what a parameter is. But why does any of this actually matter to you? How does knowing this help you make sense of the wild world of AI?
Well, for starters, now you know exactly why bigger models cost more to use. All those billions of parameters need a huge amount of computer power. You can also finally understand what an open weight model is. It's when a company releases that file with all the final tuned slider positions for anyone to download and use. And you get fine-tuning now too. That's just taking a model that's already trained and slightly readjusting some of its sliders for a new, really specific job.
Ultimately, it all boils down to this. Those parameters, those billions and billions of numbers, they are the very foundation of an AI's intelligence. They're the stored knowledge, they're the memory, and they're the engine that lets an AI do everything that it does.
So, the next time you see one of those headlines screaming about a model with a trillion parameters, you won't just be impressed by the giant number. You'll be asking the smarter questions, like, okay, but how good was its training data? And how efficient is it?
because now you know that's where the real magic actually happens.